Hey, Ian.
Oh,
Yo, what's up?
what's up, dude?
So today we're gonna finish up. What was it? What was it? Yeah, we're gonna finish up. I think we had like a one more question left from. No, three more questions from transmission lines. I think we got 9, 10, and 11.
What's 9, 10, 11?
Oh wait, sorry, not 9, 10, 11. Oh wait. 9, 10, and 12. We already did number. No, we did number 12. Sorry. 9, 10, 11. Yeah.
Is that the question number?
Yeah. I'm gonna take us right to the whiteboard.
All right.
Okay. So let me write down. I'm gonna type out question 9. What's playing in the background?
Oh, you could hear it? It's a
Yeah.
phone game.
It's a what?
It's a phone game.
Oh, okay.
Yeah. Have
No,
you heard
it's
of, what do you call it? Genshin Impact?
expansion pack.
Never mind then. Genshin Impact.
Oh, okay. Is that what it's called?
Yeah. It's a new one.
Oh, okay.
Okay. Losses, transmission line, headline, curse impedance. Application constant is seen in the source. Dude, you know what? We have very different books. That's what I'm gonna say.
Yeah, we do.
Yeah, because I went through all of these chapters, like for what's the name of this topic? Power. This is power, right?
Yeah.
So I finished power the other day, and nothing similar to this appeared in my book.
Yeah, no, it's definitely different books because what year was yours?
Year? What do you mean?
Your book.
It doesn't have a year on it. This is probably an old version.
But it's a giant one, right?
Yeah, with
Yeah.
like 500 questions in it.
Yeah, I got this from one of the officers of yeah, I got one of the officers gave it to us. Speaking of, hang on.
Was it Nicholas?
Yeah.
Yeah, he was the president for Eta Kappa Nu.
Oh, okay.
Propagation constant. Okay. Is this a man? No, I don't think so.
You don't think so? What?
Wait. Didn't you just type in the chat?
Yeah.
No, I don't think I got an email.
Uh-oh.
Why did I send it out?
No, I don't. I'm not sure. Um, I'll let Christina know.
All right.
Okay, so given the propagation constant, our first clue is definitely to convert, multiply radians per meter to multiply with the length of the transmission line. And then I believe we also need to convert radians to degrees. Okay. And then I'm pretty sure you remember from high school, if you're going to convert radians to degrees, you got to go 180 over pi. Then we times it by 30 meters to get our degrees. So, which is roughly about which is about 240 degrees. Okay. Now we have a now we have to find the input impedance. Okay, so they told us that the load impedance was okay, 60 plus 40J. And then the characteristic impedance was 50. Tangent 240 degrees. So let's see, that's about -3/2 divided by half. That's about yeah, that's about square root of 3. You know, earlier I was actually almost not gonna make it because I was a bit tired.
What have you been up to?
I was kind of sleeping all day today because as per usual, the weeks have been pretty brutal with school.
Mhm. What classes are you taking this semester?
Um, I'm taking 400D,
Ooh.
and then what else? What else? 451, 481, 482, 486, 489.
Wait, what's 489?
That's the DSP capstone.
Oh, okay.
Just trying to get, since this is my last year, I figured I'd also use time to get some project experience out to add to my roster.
Mm-hmm.
How did we get to 125?
Loading keywords. Okay. Characteristic keywords. 50.
Let's see.
Oh shit.
Whoa, what's wrong?
I think I pressed the calculator wrong or something. I'm gonna try again.
Okay.
If the load impedance 50 ohms.
So now we got to rationalize that denominator.
Yeah, I pressed it wrong. Damn it.
Okay. Okay.
Okay, I got the answer.
You got what?
Got the answer.
Let's see. What'd you get for the answer?
C.
That is correct. Then you just got to find the angle of this vector and then figure out what the length is with Pythagorean theorem. Oh shoot, then I have to times it by 50. Oops.
Yeah, that formula's messy, huh?
Yeah.
Dude, I was trying to punch in the calculator and it gave me a stack error. It means there are too many calculations being performed in the calculator and it couldn't handle it.
Uh-oh. When machines start to troll us, that's the day humanity is gonna get a taste of their own medicine.
I'll be right back.
Okay. Yep. Answer is C. Oh. Yeah, this problem was messy.
Hey, I'm back.
Yeah. Hang on. Just want to figure out the vector. I just want to figure out more of this vector problem because this calculation is kind of messy.
Mhm.
Let's see. 60 plus. see. All right, but yeah, the answer is C. Somehow, I don't know how. See, here's where the book gets a little kind of throws you in for a loop. You know when you had to times everything by like square root of 3?
Sorry, what?
You know when you had to times everything by square root of 3?
Square root of 3?
This step. This step right here.
Okay, yeah. Oh, that's the tangent of 240.
240
Yeah.
degrees. Yeah, somehow it gives you only an estimate, like 60 plus J 125 instead of 126. So I don't know where the logic comes from, but yeah, it's like after you're done, you're supposed to use Pythagorean theorem to figure out the length of your use Pythagorean theorem and then figure out what the angle is. But yeah, you got C, right?
Yeah.
Okay. Okay. We'll move on to number 10 next. Okay. Oh. All right. So basically, this problem is just a derivation problem.
What is a transmission line voltage expressed in terms of voltage of the generator?
So there's an equation we have to start off with if we're gonna start somewhere. Alrighty. So the voltage equation for a open for lossless transmission line for a lossless coaxial cable is the following. So then let's see. So at the termination point, we have to, let's assume that D is 0. And then we got to plug 0 into this equation here.
Wait, why is it 0 again?
Because it cuts off at a open circuit load.
Okay.
Let's see. Okay, that's where we got. Okay, so basically how the answer puts it, let D equal 0 at the termination point, let V1 equal V plus 0, and V2 is going to equal V minus 0. The load is an open circuit, so the reflection coefficient is 1. Okay, they didn't really dive into that detail much.
Huh.
Okay, so gamma is going to be the reflection constant, if you remember. Reflection coefficient. So V1 is pretty much going to equal V2 because of the reflection coefficient established right here. So now we could substitute V1 into the top equation here, because V1 is confirmed to equal V2. So you ever notice a pattern with these two terms, Hien?
Yeah.
What's the pattern here?
Crap. Is that sine or cosine?
That's cosine.
Oh yeah, cosine.
Yeah, it's basically Euler's form, but there's no half here. So if there's no half, that means we could safely that means we could do 2 cosine beta d. So what was it? So once we multiply that out, we're gonna get VD to equal Vgen. Voltage at the generator to equal 2V1 cosine beta d. So remember when we plugged in 0 at the termination point? Ian?
Yeah.
Remember when we plugged in 0 for D? We got to do the same thing here. So if you plug 0 into cosine here, that's just going to turn it into 1. And V1 is equal to oh, oops, I forgot a step. Oops. So if we're going to get V1 isolated, we got to do V1 is going to equal Vgen 2 cosine beta D. And then we got to substitute this equation back into V1 here.
Wait, how is a V generator defined again?
How's what?
V generator?
How do we find Vgen?
Yeah.
Because you're taking into account, let me see, Vgen. Oh, because it's the voltage at the generator when you take into account the transmission line length and the propagation constant.
Okay. So the answer would be B.
So my understanding of this problem is that you have a generator that's generating a voltage across a coaxial cable, but it terminates at a termination point because it's open circuit.
Okay.
So the twos cancel.
That's line voltage.
And
answer would be A. Let's see. Wait.
well, reason why is because this equation that I have right here, that's V1, and we had to substitute it into the generator voltage equation.
Oh.
So the twos cancel.
B2.
And then going by that logic, technically C would be correct too. Well, I mean, technically B would also be correct, but well, it's not simplified.
Wait.
What? So
Wait, so
wrong?
is the answer C?
Huh?
Is the answer C?
Yeah.
Okay.
It would be B technically too, but they didn't really simplify it in B.
Yeah. They're the same thing. What?
I don't know why they put that in there.
It's weird. Oh well.
Oh well. Okay, so number 11. Okay. So number 11. This is probably going to be a real short one. So in this equation, what units are associated with the product of the propagation constant beta and the transmission length d?
And transmission length. Especially for propagation constant. So the unit for propagation constant is radian over meter, right? And transmission length, I assume, be meter.
Because remember that equation that we wrote earlier?
Yeah.
Basically, when you convert it to its trigonometric form, you have to look at what's inside the parentheses. D is a unit of meters, and we know that cosine will only input dimensionless. Well, technically radians. It'll only intake radians, and radians are technically dimensionless.
Oh, okay.
So that means beta has to be essentially 1/meters if you're going to make it dimensionless.
Mm-hmm.
So our only answer in this case would have to be A.
Wait, but the question is asking the product of propagation constant and transmission length.
Product. Oops, I wasn't reading. Yeah,
Yeah.
it's dimensionless.
Yeah, so it should be D.
Ugh. Man, who would have thought the tutor was acting a little stupid tonight?
Don't worry about it, dude.
Then again, I woke up like almost 40 minutes ago.
Damn.
The minute I looked at my clock, it was like 7:06, and I'm like, oh shit, I gotta get going. Okay, we finished up transmission lines. Now we can do power distribution. But there's no math in here though. I'm not sure if you want to do it or do you want to just move on to motors and generators.
You want to do Maxwell equations?
Huh?
Electromagnetics. You want to do that?
Okay. Oh yeah, electromagnetics. Oh, that's right, chapter 18.
Dude, I'm gonna take the exam in like 3 weeks.
I have mine in a couple.
When is it?
15th.
Wait, what?
I have an
This
exam.
month?
Yeah. For 451.
Oh no, dude. I'm talking about FE exam.
Oh, FE exam? Oh yeah, you're taking it.
Yeah.
Fingers crossed.
Fingers crossed. Dude, my friend, he told me that don't worry about it too much. Like, he said that if you get 60% of the questions right, you're gonna pass. Let's hope that's the case. Oh my god, I hate this.
Yeah, this is the first thing we had to learn in physics, didn't we? Well, physics 2, I mean.
Jesus. Reminds me of the 350 days.
Don't remind me.
Damn it.
All right. The system consists of two protons that are 3.4 micrometers apart from each other in free space. Each proton has a charge of 1.6, 10 to the 19th coulombs. A force moves the protons 200 nanometers closer together. Most nearly, what is the change in potential energy of the system of two protons? So we're going to essentially be finding two different energy states. Oh shoot, I remember this equation. So this shouldn't be too difficult. Because what was it? What was it? Tau beta pi needed a FE electrical instructor,
Mhm.
but and this is back in like the months before the wait, was it? Yeah. It was spring 2020, before we found out that a pandemic had hit.
Yeah.
What happened was their previous EE computer tutor bailed. Well, has been bailing, so they needed me to come in. But you know what the sad thing is?
Yeah.
No
What?
stu Nobody showed up.
Oof.
So I essentially like passed out afterwards. I passed out like in the middle, and I was just like, well, there's no one here. There was only mechanical students
Wait, mechanical? Like for
for
electrical FE?
for no, because there was a whiteboard for the mechanical students, there was a whiteboard for the electrical students, and
Oh,
nobody
there's no electrical there.
nobody for electrical showed up.
Oh my God.
So I like passed out for like most of it. That sucked.
I think it's pretty common that they don't think electrical students need FE exam.
Say what?
Like, I don't know. Like people have been saying that electrical engineering students like don't really need uh FE certificate.
Huh.
Because we definitely don't need um a PE cert unless you're working with construction or whatever.
Hmm.
So yeah, I don't know. Most of my friends they are not very interested in getting an FE exam. So
So these are the two different radiuses that we need to take into consideration. And if you remember the work integral,
okay.
okay, we need to put the negative in front because the second radius is smaller, so that way we kind of, shall we say, correct the sign afterwards.
So Oh my god, there's so many formulas to work with.
This is what?
There's so many formulas to work with.
I know. That's because electrical engineering is like, that's partly why electrical engineering is so difficult because it's very brainy. So I pulled the constants out. That way it could make our integration a little less uninterrupted by all the numbers. So we have 1 r squared, 1 over r squared dr. And if you remember from calculus, pretty much that is that's going to be negative 1 over r from r1 to r2. So then the negatives cancel here. And then all we need to do is oh, not 19. Oops. 12. And then we just gotta calculate for this. Okay. So this is the answer that I roughly got. And yet somehow our answer reduces to C?
The hell?
I have no idea. Like I don't know how like it jumps from 4.23 times 10 to the negative 24th joules to 10 to the 24th joules. Like that doesn't make any sense.
I guess that's the closest answer.
I suppose. I mean, unless if we're like rounding it, maybe. All right, so this is the first problem of electromagnetics. We'll probably continue it next time we work together.
Okay.
Alrighty. And then I think right after that is when you dive into, it's when we dive into magnetism and magnetostatics.
Wait, what's the answer again?
It was C, 10 to the negative 24th joules.
Yeah, I got that. Jeez.
We got a fair amount of problems in both electro and magnetostatics. So we'll probably put our emphasis on that like in the next session or two.
All right, dude.
All right, dude.
Wait, am I the only one doing this?
It seems like it.
Oh shit.
There was a message on the Discord from another student who asked like I got an invite for like Wednesday. That was the screwed up invite I made. But
Yeah.
you're like the only student that seems to want to like show up. I think it's
This is
partly,
interesting.
yeah,
Well, because I'll be taking the exam soon, and I think you'll be put out of a job.
yeah.
Dude,
What?
I don't know. Okay, I'll see you later, man.
All right, I'll see you later, Hied. I'll see you next
Bye.
Saturday.